Alright class, here is our review for finding the distance between 2 points. If you're having trouble with your worksheet for tonight, watch this as many times as you need to. Alright, to find the distance between 2 points, first we're going to need a coordinate plane. I'm expecting you guys to draw something like this on your graph paper. And you're going to have to do a different one for each problem, so you can make them as small or as large and use as many pieces of paper as you want. Alright, we're going to label our axis. X is our vertical, our horizontal axis, right there, there it is. And Y is our vertical axis, that's our up and down. Alright, and now we have to put 2 points on here. I'm going to put one over here at X distance of 1, Y distance of 2, and my dogs have an opinion about that apparently. And then I'm going to put one over here at X distance of 6 and Y distance of 4. And it's important to remember how we label these points. The X comma Y is always X first, Y second. That can be a little confusing because when you're looking at your axis, you actually see the Y first, but the X point is always labeled first, and then the Y. So our first point would be 1, 2, 1x, 2y, and our second point would be 6, 4. Now, it's not readily apparent how to calculate this distance between 1, 2 and 6, 4. I could certainly walk 1, 2, 3, 4, 5 to the right and then 2 up, but it's better if I drop my right triangle right down there, and this is what you guys are going to be doing. And using the right triangle, you can use your knowledge of the Pythagorean Theorem to find the hypotenuse of the triangle, and notice that the hypotenuse is the exact distance between the 2 points. So all we have to do is figure out the other 2 sides of the triangle, which I already did, but I'm going to write them down here. So the side on the bottom is length of 5 because it goes from, where's my little pointer? There it is. It goes from 1 to 6, and the distance from 1 to 6 is 5, or 6 minus 1 is 5. You can think of it any way you want. You can think of it as the x value for this point right here, which is 6, minus the x value for this point, which is 1, and you get 5. And the other distance, same thing. I'm counting up 2 from 2 to 4, and I get a distance of 2, or I can subtract my smaller y value from my larger y value, get 4 minus 2, which is 2. So now I have my 2 smaller legs of my right triangle. I'll plug them into my Pythagorean Theorem. 5 squared plus 2 squared equals hypotenuse squared, which we're calling c, which is 25 plus 4 equals c squared, which is 29 equals c squared. And how do we find c? If c squared is 29, we have to take the square root of both sides. And that's an ugly square root. Square root of 29 does not have an integer answer. But if you would like, you can use a calculator and get a good approximation and then round it to, say, the nearest hundredth, which is what I did over here, or 5.39. Now it's important to remember that that is not what c is. C is the square root of 29, and the square root of 29 is irrational. And we have to remember that an irrational number is a real number in the universe, but it's a number that can't be represented by one digit over another digit or by a repeating decimal. It's like pi. It just goes on forever and it keeps changing because we don't have a way to say it with our silly number system. So square root of 29 is more accurate, but there's nothing wrong with 5.39 as long as you make it clear that you know it's an estimate. And once again, we know that that is the length of the hypotenuse, or c. All right, let me know through email or on Edmodo if anybody has any questions. And that is great work, everybody.